In this video, we are given a variety of conic sections, and we're being asked to write the standard form equation based off the graphs. We see that problem number 23 is a circle. So let's remember how the model for a circle goes. It's going to be x minus h squared plus y minus k squared is equal to r squared, where the center of the circle is the point h comma k, so the opposite of both of these, and r is the radius of the circle. So keeping that in mind, all we need is the center and the radius, both of which we can tell. I'm going to assume that this is right in the middle of the square. So the center is the point 5, 0. So according to the model, I should be able to put the coordinates of the center here and here. So that means I'm going to have x minus 5, all right, it's the opposite of this, squared, plus, now because of the 0, if I do y minus 0, that's just y. So I'm just going to have y squared is equal to. Now it's time for the radius squared. So for the radius, I'm just going to look and see, all right, how far over is it? From 5 to, so I've got 1, 2, 3.5. So the radius is 3.5. Okay, so I need to do 3.5 squared. What's that? Okay, I feel like I should go ahead and actually square this. That comes out to be 12.25. So that's it for number 23. We can see that number 24 is an ellipse. Now the standard form equations of an ellipse look like these. It's going to depend on whether or not it's a horizontally stretched ellipse like this one, a horizontal major axis, or if it's a vertical ellipse like this one. So what did we have again? This is a horizontal ellipse. The major axis is horizontal. So that means we're going to use this version of the equation. Okay, so the center is going to work similarly to the way a circle did. It'll be the opposite of each coordinate of the center, will be here and here. So looking at this graph, it looks like the center is just 0, 0. So that means when we set up the standard form equation, okay, we saw that it was a fraction plus another fraction, and it was always going to equal 1 in standard form. All right, fraction plus a fraction equals 1. Now if the center is 0, 0, this will just be x squared and this will just be y squared. So the numerators will simply be x squared and y squared. Now these models involve something, we have this a squared and this b squared. What's that? Well, the a value is the distance from the center to the vertex. So let's figure out what that is. So from the center to the vertex is here at 6. So that means a is 6. That means a squared is 36. And it's a squared that we need in the denominator. Okay, notice that a is in the horizontal direction, the x direction. So we put a squared with the x term. Now, similarly, the b value is the distance from the center to a covertex. Okay, so my b value is going to be this. All right, this distance from the center to a covertex. And the b value is 3, which means that b squared is 9. And it makes sense that because this is vertical, that means it's in the y direction. So it shouldn't surprise you that I'm going to put this 9 with the y term. So that is the standard form equation for this ellipse. So we see that 25 is a parabola. So let's look back at our notes. We have vertical parabolas and horizontal parabolas. That will determine which model we are going to deal with. Now this is a horizontal parabola because it's opening to the left. So we're going to be dealing with this model right here, the version where the y part of the equation is squared. Okay, so I think I will go ahead and write down that model off to the side. So we're dealing with this, y minus k squared is equal to 4p times x minus h. Now the h and the k will be the vertex of the parabola. So it seems clear to me that the vertex is right here. So the coordinates of the vertex will be 1, comma, negative 2. So 1, comma, negative 2, that's the vertex. So these values will show up here and here, but be careful of the order. The x coordinate will give you the x part of the equation. The y coordinate will turn up in the y part of the equation. So what I have so far is y plus 2 squared. Okay, I'm doing the opposite of the y coordinate, so y plus 2. And for now I'll just write 4p times x minus h. The x part of the equation will come from the x coordinate of the vertex, so x minus 1, as I do the opposite of this. So all we need now is the p value. The p value is the distance from the vertex to the focus. If it's up or to the right, it will be positive. If it's down or to the left, it will be negative. But we need the distance from the vertex to the focus. They did not give us the focus in the picture, but what they did give us was the directrix. This green line right here is the directrix. How can I use that? Well, it turns out that the distance from the vertex to the focus and the distance from the vertex to the directrix are the same, but they're in opposite directions. So in terms of the p value, they will be opposite signs. So let's see. From the vertex to the directrix is to the right 3. Okay, so I would think of that as positive 3 because it's to the right. So that means I will find the focus if I go to the left 3. Like this. That means that p is equal to negative 3. And the focus is right here. So if I just substitute negative 3 in for p, then this becomes y plus 2 squared is equal to 4 times negative 3 times x minus 1. So this is going to be negative 12. So I can go ahead and write down my final answer. Y plus 2 squared is equal to negative 12 times x minus 1. So that is the standard form equation of this parabola. Number 26 is another parabola. This one is vertical. So that tells us that we will be using this version of the equation, the one where the x part of the equation is squared. Let's go ahead and just plain write that down. So the model that we are working with is going to be the x minus h squared is equal to 4p times y minus k not squared. So we can already tell what the vertex is. The vertex is right here, and the coordinates of the vertex are, let's see, so 1, 4. All right, that's my vertex, 1, 4. So I can go ahead and fill in the parentheses. So that means I will have x minus 1 squared is equal to 4p times y minus 4. Whoa, did I write squared right there? All right, this side is not squared. I don't know what I was thinking right then. So x minus 1 squared is equal to 4p times y minus 4 not squared at all. Okay, so all we need is the p-value. Be careful when you're filling in these values. Don't just go automatically in order. Make sure that the x-coordinate of the vertex is going into the x part of the equation, and the y-coordinate of the vertex is going into the y part of the equation, but they're opposites. So the p-value is the distance from the vertex to the focus. So because this is up 1, I will say that the p-value is 1. If it had been down 1, I would have said negative 1. So substituting 1 in for p, really it's going to be as though the p is disappearing, because 4 times 1 is just 4. So I'm going to go ahead and just write down the final answer, which is x minus 1 squared is equal to 4 times y minus 4 not squared. 27 is another ellipse. All right, remember how those equations go? This ellipse is vertical. So that means we're going to be looking at this version of the equation, okay, the one that goes like this. So let's go ahead and get set up for it. So we have seen that whenever you have an ellipse, you're going to have a fraction plus another fraction, and it's always going to equal 1. Now, what goes in the numerator depends on the center of the ellipse. And it seems clear that the center of the ellipse is right here. So off to the side, whoops, I'm just going to write down the center. Okay, the center is negative 2, 4. Okay, so that's going to show up in the numerator like this. It's going to be the opposite of this and the opposite of this. So I'm going to have x plus 2 squared and y minus 4 squared. Okay, now looking back at my model again of my vertical, I need my b squared and my a squared. So remember that a is the distance from the center to a vertex. Okay, so a goes the longer way. So the distance from the center to a vertex I can show right here. That is 4. So that tells me that the a value is equal to 4, which means that a squared is 16. Notice that this is vertical. It's in the y direction. So the 16 will definitely go with the y term. Similarly, the b value is the distance to a covertex. Okay, so the distance from the vertex to a, from the center to a covertex is 3. So this b value is going to be 3, which means b squared is 9. Notice that the b value is horizontal. It's in the x direction. So this 9 will definitely go in the x term of the equation. So that is the standard form equation of this ellipse. Number 28 is a circle. So remember what the standard form equation of a circle looks like. We're going to need the center first. So the center is right here at the point 2, 1. So that tells me that I will have x minus 2 squared plus y minus 1 squared. Opposite of this and the opposite of this, boom, boom. And that's going to equal the radius squared. Looking back at our notes, the radius squared goes right here. So what is the radius? So just looking at the diagram, this is the radius right here. So 1, 2, 3, 4. The radius is equal to 4. So that means the radius squared is 16. So I put the 16 right here. So that is the standard form equation of this circle. All right, let's do one more. Number 29 is one more parabola. Okay, now this parabola is facing to the right. It's horizontal. So that tells us that we are using this version of the standard form equation, the version that has the y part squared. So the model is y minus k squared is equal to 4p times x minus h naught squared. The h and the k are the coordinates of the vertex. We can see that the vertex is right here. Okay, there's my vertex, and it's at 0, 0. Interesting. So since h and k are both 0, then this will simply become y squared is equal to 4p times x. Okay, I guess I don't even need the parentheses. Silly goose. So 4px. Now, the p value, that's the distance from the vertex to the focus, which they gave me right here. So this is the p value. So p is equal to 1. Because it's to the right, it is positive. If it had been to the left, I would have put a negative 1. Now, substituting in a positive 1 will really make the p go away, because 4 times 1 is just 4. So that gives me a final answer of y squared is equal to 4x. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.